Every time I look down at this thing when I'm turning it on, it gives me like a double chin.
I started off every year.
Alright guys, we're going to talk about molarity. So we're on page 49 in our notebook. So anytime we're talking about any solution in the concentration, we're looking at how much we actually dissolve in that solution. There's several different ways of calculating concentration. The one that we're going to look at in this class is molarity. Some others that you guys might see would be like molality. Okay, we won't talk about that here, but you guys would definitely, I know it sounds just like it, except a lot more L's. And then like percent, weight percent, and volume percent, so different combinations of that. So if you guys ever go on to take more chemistry classes, you guys will see that you'll have to use more than just molarity. But molarity is still probably the most common. So obviously it's a measure of concentration.
Testing Michael's a traditional TM.
Whoa, easy there. It tells us how much solute is dissolved in a certain volume of solution. Okay, so those are some vocab words that you guys learned yesterday. So solute is what we're trying to dissolve. The key word in here is solution. Notice that it's not solvent. So when you guys are looking at molarity specifically, you're looking at how much total solution you've made at the end of mixing these two chemicals. Okay? And last but not least, it is measured in moles of solute per 1 liter of solution. Again, at the very end, what's your final volume of both your solute and solvent? Okay. Okay, so the formula for molarity looks like this. Molarity is going to be symbolized with a capital M. Okay, you guys make sure you use the capital M. A lowercase m stands for molality. So don't get those two confused. Use the capital M. So molarity is equal to the moles of solute divided by the liters of solution. Okay, you guys have to have this formula as liters and moles. So if I were to give you guys grams, what are you going to have to do? Convert to moles. Good, Garrett. If I'm, not straight geometry, just molar conversions. Okay, and then if I give you guys milliliters, you guys would have to convert to liters. So the formula has to be in moles and liters. Okay, this is the only case when we do dilutions in a couple weeks, you'll see that as long as you use milliliters on one side, you can use milliliters on the other. Okay, but for molarity, you have to use liters. Okay, so that's all there is for notes on page 49. On 48, though, we're going to do 4 examples. So let's flip to 48. Here's your first example. How many moles of NaCl does 1 liter of a 3-molar solution of salt water contain? If you guys do not have your notebook or your calculator already, why don't you guys go ahead and grab that, please? Go ahead. You guys got that? Alright, so this one's probably the easiest type that you guys would see. You guys are given pretty easy numbers, and you're given everything you need, so you need no conversion. What's one of the givens that you're given, Merritt?
3 moles of solution.
3 molar, so it's a big M. So it'd be we got the molarity already. So the molarity is equal to, what else are we given, Buck?
1 supreme liter.
1 supreme liter. Get it? Liter.
That's enough.
That's 1 liter. So we're just trying to find moles. So you guys just solve for x. Pretty simple. Multiply both sides of 1 to get by 1 to get rid of your denominator. So x is equal to 3. What's your unit?
3 moles.
Moles of NaCl.
That was on me.
Pretty cake and pie, right? Okay. Next problem. 8 moles are dissolved in a total of, in a 4 molar salt solution. So 8 moles, oh my gosh, I can't even talk. 8 moles go in a 4 molar salt water solution. How many liters of total solution did you guys end up with? So again, notice that we're focusing on total solution. Okay, what's one of our givens here, Tristan?
8 moles.
We know 8 moles. Okay. What else are we given, Katie? The molarity, or 4 molar solution. So we know the molarity. So the molarity is equal to 8 divided by, we're trying to find liters. So I want you guys to write this down next to this one. When you have to solve for liters. Okay, and then put a star next to it. This is a problem that I see when you guys are given the molarity and the moles and you're asked to find the liters. For some reason, I find that kids really just do the algebra wrong for this problem. A lot of kids will take 4 divided by 8. Okay, that's incorrect. You guys will get a wrong answer for that. Okay, so this is just algebra you guys would have learned. So I want you guys to highlight that. So whenever you guys do this kind of problem, you kind of can remind yourself how to solve for this. Okay, so in order to get rid of the denominator over here, we're going to multiply both sides by x. So 4x is equal to 8. Okay, that cancels out your x up here. And then you guys go ahead and divide 8 divided by 4. Okay, so basically you guys just take, when you're solving for liters, you switch your x and your molarity, do the old switcheroo. So take 8 divided by x. Switcheroo. Okay. So as I said, that's just a mistake I see about half of kids every year make. Just the simple algebra. So just make sure you guys know what you're doing there to solve for that, okay? Cool. So what's your answer come up with then?
2 liters.
So x is equal to 2 liters. Okay. Easy peasy lemon squeezy. Number 3. What is the molarity of a solution if 0.75 moles of NaCl are used and then filled to 4,200 milliliters? Okay, so what's the first thing we're going to have to do to solve this problem, Mick? Convert milliliters into liters. Okay, so that's pretty simple. 4,200 milliliters to liters. Okay, so how many milliliters are in a liter? 1,000, good. 1,000 milliliters is 1 liter. So you guys are dividing through by 1,000, basically just moving your decimal over 3 places. 1, 2, 3, to the left, to the left, to the left. Everything you own in the box to the left. Is it to the right or to the left? To the right, to the left. Oh no, there needs to be one of those that are like 2 decimal or 2 syllables. Alright, so we got 4.2 liters. What's the other piece of information that we have then, Maddie?
The moles.
How many moles?
0.75.
Great, 0.75 moles. Divided by 4.2 liters. That's going to be equal to our molarity. Garrett, tell me what you get.
I got 0.179.
So we'll go 2 decimals, 0.18. You guys can write it like this, 0.18 capital M. That means 0.18 molar. Okay, you guys can also write that out, 0.18 molar. Okay, and just make sure you guys are using a capital M. Otherwise, you're telling me you did a molality, which is incorrect, not a molarity.
And then, is this what we use on the one business proposal thing? Right?
Yep, we did this really briefly when we did the chalk lab. Okay, just to help us figure out how much we needed.
No clue what we were doing.
But now you do. That's why I did it with you then. Okay? Last question. What is the molarity of a solution if 56.6 grams of NaCl are added to a solution filled to 2,500 milliliters? My green marker's in pretty good shape. My red marker's like all frayed at the end. I must get angry when I use my red marker. Oh, my blue one's really bad. That must mean I use it a lot more. The black one's probably in good shape too. Apparently I have preferences of color.
Do you have
But you
What?
don't ever use
What?
You don't ever actually use that color.
what's your
But then I like select other. But I like the blue marker. It's the worst shape.
Oh, don't tell me metalhead.
Oh, okay.
Poor guy.
The salt has
That might have been
It's
bad.
smaller mass. Rachel, what's the first thing we gotta do here? Change the grams to moles. Good. Tyler, what's the next thing we're gonna have to do?
Change milliliters to liters.
Milliliters to liters. Good. All right. So we started with 56.6 grams. Okay, I wrote the molar mass up there for you guys, and because I was gonna forget it, so we're going to moles because we need it to be in moles. 1 mole is 58.44 grams. Garrett, what'd you get
Oh,
for the number of moles?
I got 0.095.
What? 0.97? That's
Oh,
correct.
I didn't.
0.97 moles. Okay, your grams cancel, you're left with moles. That's the answer. Then we got to do the milliliters. How many milliliters did we start with? 2,500. There's 1,000 milliliters and 1 liter, so 2.5 liters. And then you guys can go ahead and plug those two numbers, 1.97 moles.
It's just not just 0.97.
Oh, I started to like square it, I think. My bad. 0.97 moles divided by 2.5 liters is going to be equal to our molarity. What is our answer?
0.387.
0.39. And how do we label that?
Big
Wait,
ol'
how's
M.
it 0.3?
A big ol' M. Good, Jocelyn.
Oh, it's 0.97. Okay.
Not 1.97.
Yeah, I was like.
You are welcome.
Okay. I'm going to pass you guys out your worksheet for today. I'm just going to take and send some around. And then we'll do number 4 together. Take one, pass it around. Pass any extras forward, please.
Oh, you're so easy,
You want to actually like
You lay down, you just go on your back and stuff.
That's well, paper cuts hurt.
Make them go quick, guys.
That's just.
Yeah, come on, Destiny. Let's hurry.
While you guys are getting them, why don't you guys go ahead and calculate the molar mass from for lithium sulfate. We're going to need it. You'll need your periodic tables. Yeah. Easy, Tristan.
Haven't seen that in a couple days.
Okay. Okay, so what's the first thing? This question says 734 grams of lithium sulfate are dissolved to make 2,500 milliliters of solution. What's the first thing we're going to have to do, Destiny?
turn grams into liters.
What? Turn grams into what? Into what?
Liters.
Into what?
Am I saying it wrong? Like, is this not right? Oh, moles.
Turn grams into moles. 70. What's the next thing we're going to do?
Let's see, turn milliliters into liters.
I thought you were going to say moles.
Profit.
Turn milliliters into liters.
It's not on the board. Keep going.
I'm so confident with that
answer.
Oh.
There you go. Oh, no, too much.
Too far.
Now you can see your head. Oh, that works. That's good.
Okay. What do you guys come up with for your molar mass?
I like 2. No.
What?
109.96.
Anyone get anything different?
109.95.
109.95 is correct.
Oh, it's
Close. Okay. So we'll go ahead and take 734 grams of lithium sulfate. Turn that into moles. 109.95 grams per 1 mole. What do you guys come up with for your number of moles? Katie. How many moles is that?
$6.68.
6.68 is correct. Okay, and then we need to turn our moles into liters. We had 2,500 milliliters. So move it over 3 spaces to the left. So 2.5 liters. Go ahead and plug those in. 6.68 divided by 2.25. Grace, what do you come up with for your molarity?
What? 2.25.
29 cents.
I don't know.
Oh, no.
Lay off of me, Destiny. Just joking, you're right
Oh
though.
my goodness.
What did you get that right, Grace?
I went off what she
2.67.
said.
2.67 is correct. What's our label for that, Buck?
Thanks, Mr.
Molarity.
Big M.
Big M.
Big M, or you guys could write molar as well.
Big old.
Okay.
Molars.
Let's take a look really quick at the last question. I do not want an answer for you guys. I just want to give you a beautiful visual for you guys to dream about tonight. Okay. In my hand, I have a 1 liter vessel. Okay, quiet guys. Shh. 1 liter vessel, okay? This is your scenario. You have 2 solutions. Okay, the first solution, I took 1 mole of salt. So I put 1 mole of salt in there, and then I filled it up to 1 liter. Okay? The second solution, I took 1 liter of water, and then added 1 mole of salt. Okay? I don't want an answer. I just wanted to explain it to you guys. Again, first solution, I threw salt in first, and then filled it to 1 liter. So total 1 liter. Okay? And the second solution, I got a total of 1 liter of water, and then I added 1 mole of salt to that. Okay, do the 2 solutions have the same concentration? I don't want an answer. Explain why. You guys will do that on your last question on there. Okay, this is due tomorrow. If you guys are going to be gone, I'll give you guys the worksheet and have you guys write some formulas and stuff down so you have that for tomorrow. Tomorrow in class, we're going to have a worksheet that's a little bit more complicated and a little bit longer than this one. Okay, but I'll help you guys out, give you formulas and molar masses. You guys will help each other on molar masses. The other part of tomorrow is dyeing Easter eggs. Rough day. Okay?